So the points that I'm going to discuss in this session are going to be on the types of interviews that you might come across, the preparation strategy, the books and blogs that you should be following for good preparation, CV preparation, how do you prepare CVs, what are the frequently asked questions, the best practices in interviews, and what are the myths associated with data science interviews. So let's start with the types of interviews that we can actually categorize. So the types would depends on whether you are a fresher or an experienced candidate, what kind of role that you are applying to, and given that data science is used in all kinds of business, so that will also depend on the business concerned. Um, So if you're a fresher, that you will be asked questions on theories, and you wouldn't be having much of industry experience, unless of course you have done some internship. Then you can expect questions on your internship project. Otherwise, you will be asked mostly what you have studied in college or what you have learned on your own. So you'll be asked questions on probability statistics, machine learning theory, optimization techniques, programming languages that you have learned, basically R, SAS, MATLAB, Python, SQL, and if you have other general purpose programming language skills like Java, C Sharp, .NET, that is always an add-on. Then you'll also get questions on puzzles. So that's one good way of analyzing someone's logical or analytical skills. And then you also face questions from your academic projects, like many master's and bachelor's degree demands an academic research paper at end of the semester. So that's also going to be important if you have done that. Research paper that you have read, and your ability to read a research paper and interpret it, understand it, and then use it for problem solving. That's also one area that the employer is going to be interested in, because in data science you will be facing a lot of challenges that you can actually solve by referring to the many of the resource papers. Okay. Internship, if you have done internship, you will also get questions on internship. If you're an experienced candidate, you will be the questions that you will be asked will be similar to what you have you would be asked if you are a fresher. Apart from that, there will be questions from your industry projects, because you are already an experienced candidate. So people will ask you real world projects that you have done. If you haven't done data science related projects, the projects that you have done in other domains will also matter. So question related to domain will also matter a lot. And then if you have done data science model building in industry, people will ask you how you did that and what impact it had on the business. So you should be able to communicate that properly. So that's basic difference between an interview between a fresh candidate and someone with experience. The second most important thing is the type of business that you are applying to. So if you're applying for financial service companies or banks, hedge funds, non-banking financial corporations, investment banks, and so on. So there, what matters is the knowledge of products. If you have good knowledge of financial products, you will have an edge over other candidates. Regulatory knowledge, banking products are always under heavy regulations from central banks, from international regulatory bodies. So that will matter a lot. And there will be a lot of questions on core statistics. I mean the statistical theory, if you are going to work in financial service. So there is there's a notion among people that data science is all about understanding the application of machine learning technique, right? You do not understand the theory very well. But if you're working in financial service companies, you have to be very good at theory, because financial service companies cannot implement something which they don't understand, and they have a lot of respect for simplicity of the models rather than over complicated models which nobody understands properly. So one has to be really good at understanding theory if you want to work in financial service companies. And statistics heavily used. The adoption of high-end machine learning models in financial service um, is is happening, but it is heavily dominated by statistical models than machine learning models. E-commerce and technology. So in contrast to financial service companies where theory is the utmost important thing, than the applied, or rather theory is as important as the applied techniques or your skills in applying models. In e-commerce and technology companies, what is more important for you to know is to be able to build a model and implement it properly to solve the business problems. So you may not understand the model very well. You may not understand the mathematics behind it. If you have a high level understanding, that is also good enough. You can actually go ahead, build and implement a model. As long as it's working fine, nobody will care about your understanding of the theory of the theoretical understanding of your model building process. It will be heavily coding based, so you should be really good at writing programs and prototyping it, implementing it, and so on. In the other sector, it will be a mix of both these types of differences. So the reason I spoke about financial service and tech sector is because they are complete contrast, and it all depends on regulations. Whenever you have a lot of regulations, then it has to be very well documented, very well written, understood, and so on. And there you will find the importance of knowing the theory very well, because your model will be audited, your model will be validated by regulators, and they are going to keep a track on what model you are building. So you will be answerable for everything that you do in a financial service company. So one has to be really good in theory if you're keen on working in financial service company. For tech and other areas where your application skills will matter more than the theory. Good to have theory though. It also depend on the role that you are going to apply for. So given that this industry is very new and they're not very well defined roles, there are a number of roles that you will be applying to, and in companies you may not have this role called data scientist all the times. You will have various types of there, because this has been there in many companies for a while now. It's been a couple of decades now. We have been using quantitative models to solve business problems. So there have been many roles, and it may not be data science all the times, but it will be somewhat related. So for an analytics manager, you'll be managing a lot of analysts, analytics professional, data scientists. So you should be really good at understanding models and applications of models at a very high level. But your primary skills will be project management. So you should be a really good project manager, but understanding of these models are very good. So people who have really good project management experience but may not have deep or hands-on experience with analytics, if they understand analytics at a very high level, they understand what models are, and they understand the jargons used, they can always fit into a role in analytics as well. So they need not think that they do not have that hands-on experience or that that ground level experience. That is not very important. What is important is you should be able to understand it. If you are applying for a data scientist role, you should be really good at building predictive models, prototyping it and implementing it. It should be really good at writing really good code, and it's more like a hacker position where you actually you're good at finding a problem and solving it using some sort of an algorithm, and you should be write the code for it to implement it in production. So it's an end-to-end tech job. It's heavily technical. It's more like a tech job, and one should be comfortable with machine learning, statistics, programming, and so on. If it is a statistician role, because statistics is a well-formed academic area. It's been there for many decades now. So you should be sound. You should have sound theoretical knowledge of statistics, like design of experiments, survey data research, econometric models, and so on. You may not be really good in coding. It's good to have really good coding skills. But if you are comfortable with using SAS or SPSS, then that's also fine, because your job will be to build statistical model, do statistical research, and there will be IT team. There will be a separate IT team who is going to implement it, or which is going to do all the IT related stuff. Once you have built the model. For a market researcher, then it's more of a research job, wherein you actually have proper understanding of marketing science and the models used in marketing science. You should know the cross-selling model, direct marketing model, and so on, loyalty model, and so on. And you should have good understanding and applications knowledge of R, SAS, and SPSS, and so on. If you're a quantitative business analyst, and this is a role that you will find in financial service companies, where there are many business analysts working in banks who understand the machine learning or statistical model very well, but they haven't built a model ever. They're basically people who actually understand business very well, and they talk to the business, they get requirements from them, and then talk to the IT team and get it done by the IT team. So they're more like a mediator between business and the IT team. So they are the people who should understand things very well. So they should have sound understanding of model, IT, business, and if you are able to prototype it for your developer, that's always a highly desired skill. Analyst is more of a general skill or general role in many companies, whether it's financial service company or e-commerce and so on. So data analysts are normally people who actually collect data, and they provide insights from the data to the management. But you cannot provide this good insight if you don't have a good understanding of predictive models. You can obviously give insight from visualizing data, but doing forecasting, knowing marginal impact. Okay, so what is important is forecasting, marginal impact, marginal effect, and then so these are two important things that you cannot do just by looking at the historical data and by plotting, by visualizing the data using plots and all. You cannot do that. So that is a limitation of a traditional data analyst, that it's limited, and that's why it's less paid compared to a data scientist. So if you know how to do forecasting and how to come up with marginal effect, you would be you'll have a higher demand or higher pay compared to a traditional data analyst. Preparation. How do we prepare for